Whoa. This book is wrong. And welcome to Desk of Lady Ada.
Hey everybody, and welcome to the Desk of Lady Ada. We're in the dark void, but soon we will be doing electronics. We've got some...
That's me in the background, you can't see me.
Yeah, it's just Phil, it's just gigantic and very goth. We have a couple quick updates. I thought we'd do a little bit weekend update. You like watching Weekend Update on SNL?
That's right.
Weekend Update at the Desk of Lady Ada. So, let's see, we got a couple updates. One, you got the new Make magazine. You got it from the magazine store.
Yeah, we got it. We were walking around and one store had it and we bought both copies.
There's only two.
And we'll show that off.
We got that. We've got a little TFT display, which is adorable, that I'm working on a little prototype. I just want to show it off. It's so cute. And I wanted to maybe just tell people about this new Learn Guide that I worked on all weekend and maybe do a very quick MakeCode demo.
Okay, what do you want to do first?
Let's show the magazine first.
Okay. So if you like this, tweet pound make V57 and then put a space and then put at make. Or just put, hi, at make, space, pound make V57. Let them know that this is a cool thing that they did. Hackaday posted up a link, Brian Benchoff, that you're on the cover. So thank you, Brian.
Yeah. Do you want to shrink me down a little bit so I'm not...
Yeah, I'm going to shrink you down a little bit. Yeah, we'll shrink you down, and then you'll be able to show some of the pages
Yes.
inside this magazine.
I'd like to be small.
Yeah, we'll
Make me small.
we'll shrink guys Lady Ada.
Make me small.
Beepity 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 beep.
Thank you.
Okay.
Okay, so this is the boards guide. So there's actually a bunch of stuff in here about boards. There's a lot of ads. Check this out. Some cool things. And then, oh, this is neat. So this is the thing I'm actually going to show in a bit, is MakeCode. So MakeCode is, used to be called PXT. They have it for Microbit, but they are doing a launch at Maker Faire using Circuit Playground. So do check it out. I think you'll enjoy it. If you're at Maker Faire, check out the Maker.
Yeah, you can go to makecode.adafruit.com.
Yeah, and this is the Alasdair Allen. He wrote a really nice article about boards, and it's actually kind of a good, it's really interesting. He talks about Raspberry Pi and ESP8266 and Arduino and FPGAs and 101s. So here's some of the boards. So for robotics, BeagleBone Blue, and then for, I guess, higher-end robotics, the BeagleBone Blue is only like $80, but then for higher-end robotics, the NVIDIA Jetson, which I'll be honest, I have never heard of this before, but I guess it's a new single-board computer. It's got like parallel processing, visual recognition. This is for like serious robots, like very, not like little rovers, but like robots that do things. For educational board, the Arduino 101, very interesting. Intel's doing a lot of work with the 101. They're pushing it kind of hard. We did a project with the 101. It is a nice board, comes with Bluetooth. It's Arduino compatible, has sensors built into it. It's a different chipset than people are used to because it's an Intel. I think it's a Quark. No, Curie. It's the Curie chipset. It's got a neural network that you can use, but there's like not a lot of documentation about the neural network. And then Microbit is another winner. So we actually have this available for sale now. We're the first distributor. Very interesting board. We'll be doing more Microbit projects, but NRF51, the LEDs, also MakeCode compatible, which I think is pretty cool. For IoT boards, there's the Raspberry Pi Zero W, which like people know and love. It's the $10 Raspberry Pi with Wi-Fi, very much loved. For other boards, the Feather Huzzah. It's actually a photo of the Blue Fruit. I think maybe I sent them the wrong photo. But the ESP82 based Feather is one of their favorites. For art and wearables, SparkFun MicroView, cute little OLED, Arduino compatible, and Circuit Playground. This is the original Circuit Playground because this Express hadn't come out yet by the when they wrote this article. And then there's a really cool interview with Gordon Williams who did Esperino. Here's the table of boards. You can compare and contrast a lot of them. And there's a ton. And then there's a really nice article. Here's me. So I actually had to throw these Circuit Playgrounds in the air. These are rejects. I just had to keep throwing them until we got like a photo of all of them floating. And here's after we threw them, they're on the ground, and I just sat on the ground. Here's Michelle and Vance. They're pretty cool. Here's me at my desk. This is right after or before we did the photo you can see here. I've got this little like Watson robot and some testers and my mug. Vance doing some rework. This is Sam and Jacqueline, Trevor, Kathy, Adafruit team. This is our team photo that we show on the Adafruit Ask Engineer every week. And then just a lot of stuff like Gareth did the article. He asked me a lot of questions about how to run Adafruit and how I design stuff and like what do I do. There's some details and stats. There's some good lessons, 10 lessons for building an open culture. You can be a good business and you can be a good company and a good business. Open source isn't a business or a marketing strategy for us. It's the DNA of our company. It's part of what we do.
I like the illustrations they did.
Yeah, for metrics, if you're not measuring things, you cannot improve them. We have a weekly all-company meeting called State of the Fruit. That's on Fridays at like 5:30. And we are transparent with all parts of the business early and often. Every person in every department, one person from every department talks about what's going on in their department. Skills can be taught. Good people making good decisions should be the focus on what's celebrated. Celebrate others. It's not just about you and your products. Traveling takes too much time. Use the power of the internet, which is what we're doing right now. Publish frequently, from videos to blog posts. My desk of Lady Ada. Say no to things. It's not about what you can do. It's more about what you will not do. Get a good trademark lawyer. If you're open source, you're giving away everything but your name. It's important to protect it. You do not need a fancy, and finally, you do not need a fancy office or building to do great work. Great work can happen anywhere, even in an apartment.
Yeah.
And that's cool. And then there's this article, which I haven't finished reading yet, about the RISC-V. So that's kind of cool. And there's an article by Zach about the microbit. So that's kind of cool, too, because I'm psyched about the microbit. I think the microbit Circuit Playground Express are like going to be the next two boards that are used in education. And that's it. There's more, but
Yeah.
that's the...
So it's in bookstores soon, newsstands. Subscribe to Make. I think the digital one is out for sure. I'm not
Yes.
sure how it works if you subscribe now, but check with Make. And then we're going to try to get some copies in the Adafruit store too.
Okay.
Okay. What's
So
next?
that's that. So next up, I thought I would show this little TFT because it's just so cute. So I actually, here's a funny story. So somebody actually mentioned in one of the chats, one of the Desk of Lady Adas, they mentioned like a USB power meter that had a TFT in it. They're like, oh, check out this USB power meter. Because, we have little ones, but there was like a really nice color one. I don't remember the name of it. And I Googled for it, and I found it on like AliExpress. And the thing that was interesting to me about it was not the USB analyzer itself, but the fact that it had a really small, high-resolution color display, which I've been looking for. So most color displays are like pretty big. They're like, like 3.5 inches, or like, we stock one that's 1.44 inches, but even that is kind of chunky. It's rather big. And what was interesting about this little USB analyzer, it was like very slim and thin, but the display was very clearly high res because it had an image on it. And I was like, whoa, that looks like a really high res image. And so so I bought one, and I took it apart, and I found the part number on the back. Well, not a part number, but like a description. And I counted the number of pins, and I kind of got a feeling for what to look for, to how to find it. And I contacted some of my TFT suppliers. And one of them actually did have, equivalent, not the exact same, but a similar resolution. Usually the TFT itself is common, and you get different connectors from different suppliers. I'm not exactly sure how that works.
What's the max resolution on the screen?
This one,
Yes.
this is 160 by 80. So I can show that little demo. What's neat is it's compatible with the ST7735, which is a display that we stock. So it's so high res, I gotta really zoom in here.
Are you okay with some other side questions as you do this?
Yeah, sure.
All right. If someone wants to buy their first soldering iron, what do you suggest?
I think a Hacko is a good.
Yeah, we have them in the store. Whatever's in our store is something that we suggest. We could carry a billion different types, but we only carry a few.
Okay, so I'm gonna pull off this protector.
Hacko is one on our desk right now.
Yeah, we have a Hacko FX88. It's good with all the different tips. So this is the display. I'm still like hacking on getting the exact driver, making it work out. Right now it doesn't quite like it overprints a little bit. You can see the really wonderful resolution. This is actually a higher density resolution than OLEDs, and this is a full color display, 16-bit color, and luckily enough compatible. You can see it's compatible with existing code. It's just the code that I have is for 128 by 160, not 80 by 160. So all I have to do is in the code just make it so it does the clipping, and for the size of the display. So I made a little breakout for it. And what's neat is you can even see this display is thin enough I can make it into a feather wing. Because I wanted to have a color feather wing display, but I couldn't find a display that was skinny enough that would fit between these two headers. So I can even move this down. Here, I'll unplug this and then I'll just move this down a little bit to show how it's, hopefully
Okay, here's a side question. What do you use to debug a 32U4?
I don't really use a debugger. I just sort of practice.
Okay.
Hold on, I think I got this pin wrong. There you go. So yeah, you can see it. This display is just the right width to go between the connectors, so it'll be a nice little feather wing with this beautiful color display. So that's a nice little thing that's coming up soon. But I'll have the breakout first. And this breakout also is just so small, but it does fit level shifter and an SD card slot, so you can have little images on your little TFT. Don't know what this is used for usually, but it'd be good for, it's probably used for little small wearables, like little medical devices, maybe little MP3 players.
Folks in chat are looking forward to SSHing with that. It's going to be a cool little display. Yeah.
Yeah, you could use it with a Raspberry Pi. It's going to be small. It's only like maybe 30 by 20 characters, maybe 30 or...
Do you have a touch layer over the display?
No, this is just the display. I don't even know if you can get a touch layer made this small. This is just so small. Like if it was resistive, you run out of space, capacitive, it would cost, $10,000 to get it made. So I'll probably just say, hey, look, there's no touch on this one. But very, very cute. I think I might have, like a button GPS, little buttons, or maybe a joystick that goes with it that would make it possible to use. But very high res.
Like a monocle.
A little monocle. Yeah, I could use this for
Okay. What's next?
little eye displays, maybe. Okay, so the next step was let's show the feather guide.
Okay. I'm going to keep it small.
Yeah.
A little bit bigger.
So I just finished writing this guide, so you can check it out. This is Interesting Adafruit Feather. So I basically made one big guide for all of the feathers and feather wings. So I just sat down. There's one feather that's not done. This is the Sam R feather that is coming out. But other than that, every feather is in here, from the basic ones.
Could you put Tetris on the little screen?
You could.
The question just came out. Okay.
Very, very small Tetris, but you can do it. Wi-Fi feathers. Compare, because basically I had to do this once the ESP32 and the NRF52 came out, because the ESP32 and the NRF52 are similar but not quite like other feathers, and I was like, I need to have something that compares them. So this guide compares, the ESP32 with the Wicked, with the Wink 1500.
Yeah, everybody asked for this, so we just did it.
Yeah, and we have a little guide, talks about the graphic displays. So right now I have this black and white OLED, 128 by 32, and this TFT that's larger and has a touch screen, but it's 320 by 240. So what's nice is the little TFT I just showed will be right in between. It'll be higher res and color than this, but not as big and touch friendly as this. So it's kind of cool. RGB pixel wings and the 3 different relay wings. So basically every feather is in here, pretty much. There's like 1 or 2 that I have to, like the Express, I didn't make it in here. We have a little page that talks about which feathers can run CircuitPython. So, this one is designed for CircuitPython, and then these are ones that can use CircuitPython, but like not as well.
Yeah, folks say, thanks for making a guide for all the feathers. I don't understand them as much as Arduino, so it really helps see the whole lineup.
Yeah, there's just a lot. I mean, there's like 75 boards, so it's just like, there's no like one quick page.
We usually go by projects too, like what do you want to do? But in that article on Make, we talk about, so every Friday at State of the Fruit, our all company meeting, it's only half an hour. It's not like a town hall that you always hear about at companies and when they're just like laying off people. Ours is called State of the Fruit, and at the end we do hug reports. So I think this counts as a hug report from the chat room. Lady Ada, good work.
Yay! Yeah, so like all the different Bluetooth feathers, like the NRF52, how does that compare and contrast with the Blue Fruits and ESP32? Like, there's no real example code for a lot of the stuff yet in Arduino, so I haven't looked at it yet. Although I think it's slowly making it through the IDF into Arduino. So check out this guide. It also has the history of the feather, so you can go through and read about like how did I design it, what was I thinking, what happened in which order, and we'll be adding more. So I've got that Zigbee feather I'm working on, and a bunch of other feather wings. I have to do a sensor feather wing, and I'm trying to just design one once. So once that's done,
it's cool to see other companies. Maxim made a wing, MCCI made a wing, so the wing format is getting adopted. And I think, shields are big, and those are, historically Arduino. And then there's hats and fats, and then there was capes, and then we have wings. There was blocks for Edison. So I really like the wing form factor, and I like that companies we find out about it after they do it.
Yeah.
Bunch on Tindy.
Yeah, and like people are free to make feather compatibles. It's not patented or copyrighted. The name is trademarked so that
Yeah, don't call it feather.
Just don't call it a feather because it's our way of making sure, because we don't want people to basically make incompatibles.
Fun side story: if you're a trademark enthusiast like I am, have to be. Shield is registered by NVIDIA, and so I don't believe Arduino was able to get Shield as a trademark. Here's a question about the TFT.
Yeah.
Do you program the TFT programming and processing? What would you do to program it?
Right now I'm using the Arduino library. The chipset is called the ST7735, which is a very common chipset. I believe we have a driver for it in CircuitPython or MicroPython.
Yeah.
Vaguely think that we may have done it.
If not, we'll get to it.
If not, we'll get to it for sure, because if I make a feather wing, this is another nice thing. It's having all these feather wings. It makes it easy for me to check off, like, do we have CircuitPython drivers for all of them? And we have CircuitPython drivers for, I think, like at least 80%. A couple of the newer ones maybe we don't, and some of the wireless modules don't because they're very complicated.
Okay, what's next?
Okay, so that's all that stuff. So people check that out. I'll keep working on that. I made it public, but I'm going to keep working on it. Like you can see, I didn't do the Radio Wings page is still empty, but I'll get to that. So next up, I want to show MakeCode because I thought that was neat. So MakeCode is one of the platforms that we're targeting with Circuit Playground Express, which is coming out on Wednesday. Yes, we've already built all the boards, so we're going to have a developers release on Wednesday for the Circuit Playground Express for people who want to get one. Keep an eye on Wednesday or Tuesday, and we'll put them in the shop. Not a lot, and they'll be limited to one per person because we only made a small run. And we're still working on all the support. It's very early still. Like, a lot of optimization has to occur. But one of the things that is working pretty well is MakeCode. So MakeCode is like a Microsoft project, and this is really neat, and I'll talk about it more in detail, but basically they wrote a linker for Cortex M0 chips in the browser. So it happens in JavaScript, which is cool because it means that you can, like, you know, with MicroPython or CircuitPython, the interpreter is in the chip. Here you're actually still writing at the chip level. Like you can write registers and you can use DMA and like low-level functions of the Cortex M0 chips. But you can program it without a compiler because it's linked in the browser, which is like pretty awesome because it's exactly what you can do now. I mean, if you can run a MAME emulator in a browser, why not write a compiler linker in the browser? Like you can do it. It's actually not that complicated, and the ARM chipset's very well documented. So it's not compiling so much as linking, I believe. I mean, there's some compilation, but it's a lot of linking. And it's open source, and basically allows them to have a way to program chips, again, completely in the browser. And even though it's hosted on Adafruit, you can run it locally. Like you don't need to have an internet connection to run this code. It allows you to do a block-based programming system that creates binary code that you run. So this is neat because a lot of Scratch programs, like a lot of Scratch type block programs, only let you send Fermata commands to a program. Like your board has to be running Fermata, and it just sends commands over serial. This is actually making standalone binaries that will run on your board. And so it's for Cortex M0 chips. Right now they're only supporting Microbit and the Circuit Playground Express, but hopefully they'll support more boards in the future. And it's neat because you basically get to make projects using these blocks. And so there's no, if Python is already like, you're like, oh my God, that's so easy. You don't even have to deal with memory management. This is going to blow your mind because it's fully threaded for you already. So you don't have to even, like, it's all event driven, but you don't have to manage your events. So I'll toss this out to show how this works. So you start with some basic blocks like, on start, and you just drag these blocks. And for example, over here there's an emulator, so you can see what's going on. So let's say I wanted to do this rainbow animation, and I want to play it forever. So when I click this in, the emulator restarts, and you can see what it's going to do. And let's say I want to download this. I'm like, okay, I want to have this happen on my Circuit Playground. So then what I do is I go to my Circuit Playground overhead. Can you just go to the overhead really fast?
Yeah. You're going to get bigger. Boop.
Oh, sorry. I grabbed the wrong one.
You have too many Circuit Playgrounds.
Huh?
You have too many Circuit Playgrounds.
I know. Well, I grabbed it. I was like, why isn't the bootloader working? Okay. So you plug it in, and all green means the bootloader is running. So then I go back to the computer. And I click.
I'll shrink you down.
Oh, yeah, it should be down. I click download down here. And by the way, you can play along. You can go to MakeCode.adafruit.com and try this out. Save the file. I'll click down here. And then what I do is I go to my computer and I have that CPlay boot, that's that mass storage bootloader. And then here I open up the my downloads. Hold on, let me just download this again.
Hug report and shout out to Microsoft for making something very good, open source, and with the goal of helping young people or all people learn programming. And best of all, this is the fastest way for us to do really quick demos. Even at Adafruit, where we write firmware and lots of code, when you just need to do a very quick, like, I just want a rainbow pattern, just like it's the fastest way to do it.
So then once you have that download, you can say I've downloaded like 10 other items, but you just click it and you drag it, and it immediately reboots. And then can you go to the overheady?
Yeah, I'll do this one.
It's now running that software. It's running that rainbow loop. So then you're like, okay, well, I want to make it do something maybe when I press the buttons or like slide the switch. So can you go back to the computer? I'll make it do some things.
Yeah. Someone asked an interesting question. They're 38, no computer, electronic background. Where should they start data? I would say something like Circuit Playground or something like Microbit first. Microbit, then Circuit Playground, and then Feather.
Yeah.
You're going to be able to do projects in 5 minutes, and you won't get discouraged. So that's where I would start. Not because you should start basic, but because it is very rewarding to do something within 5 minutes, and you're like, wow, I can see progress ahead. So you want to go back to computer?
Yeah.
All right.
So something I can do is, for example, I can have different inputs. So like, for example, maybe when button A is clicked, I can have it play music. So maybe I'll have it play the power up.
Okay.
So one thing I can do is I can like try it out in the computer. So if I click this button,
Okay, the computer
it
made that sound.
Yeah, it simulates what it will be like. So
Okay.
that's what happens when you press the
But,
A
but
button.
what happens when it's on the device? Does this really just work?
Yeah,
Really?
but let's maybe do something different. Let's do some more.
Does this work on a Chromebook?
This will work on a Chromebook.
Oh boy.
This works on everything.
There's a big New
This
York
works
Times
on-
article
This
about
works on Android.
Google got like 30% of the educational market. And you and I were talking about this, and it makes sense. I mean, schools aren't going to run mail and basically Google Docs. I can see why. And then Chromebooks are pretty inexpensive, and now there's this thing. So we might live in a world where there's a Android or Google OS thing, Gmail, Google Docs, and then Microsoft MakeCode.
Yeah.
MakeCode.
And maybe I'll make this a little bit less bright. So I'll set the brightness to be 10 on start. So it's easy, like, you can just kind of like have all these parts dragging around.
It's fun. It's like being an electronic DJ.
Yeah, a little DJ. Okay, so now I have different, like I have a project where it does the rainbow, and if you click the A button, it plays power up. If you click the B button, it plays birthday song. So let's try this out. Click B.
It's a lot. We're in an apartment.
Yeah, I know. Maybe I'll do a shorter thing.
Oh, good question. So can you hook up Circuit Playground to an iPad and code an iPad? So here's the deal. Probably not. Not physically, but who knows? I'm very interested in Swift playgrounds working with Circuit Playground. There's Bluetooth, and so we have ideas. So more on that later, but a lot of it is how do we get that to work? Maybe there needs to be some type of Swift to Circuit Playground, but the names really line up well, so we'll see.
It's challenging because Apple like locks down everything. You can't. If you could plug in a disk, like a USB key, you could use it because it uses mass storage, but that's not even exposed in iOS. All right, so let's download this to our board, and then we'll try it out. So let's see, save, done, and then we go back into the bootloader mode. And then let me, I forgot I gotta keep this open. Drag the program on. Okay, and then can you go to the overhead? So now, when I press the button, oh weird. It totally worked like 1 minute ago. Live demo.
Is that the same? Did you do the other Circuit Playground? You had two different ones before.
Oh, maybe I did. Maybe I grabbed the wrong one.
Yeah.
Hold on.
We have a desk full of Circuit Playgrounds. They're all plugged in. So let's see what happens. Download completed. Maybe I grabbed the wrong file
I
and the
don't
wrong
know.
Circuit Playground.
Let's find out.
Yeah.
Oh no.
Did you break it?
I probably broke it. Let me try my other one.
Try your other one.
Because I tried this demo earlier. Oh yeah, I probably used one of my broken ones. Anyways, here's the music. So it uses the little speaker, and the audio comes out of the speaker. And then you can change the brightness, and you can have it like do something when you shake it or when you touch a pin. So it has all the like different inputs and outputs that you would expect from like, the things that you'd expect if you're using Arduino, but you don't have to use Arduino. It's like all in there already. So it's kind of neat. And what's cool is that you can like play with the simulator just to try it out. Like you can simulate like lights, buttons, music.
We got people testing this on their Nexus and their Chromebooks. It's working.
Yeah, try it on your it definitely works on Android, Linux, and Chromebook. And we are coming up with creative ideas for how to make it work with iOS. We may have to do something like what Love to Code, Bunny's project does, which is use audio. Because there's just like no other, but even then, there's no headphone jack, so you'd have to use a headphone adapter. Or we can wait until we have the Bluetooth version of Circuit Playground, which will be a while
And to
from
be
now.
clear, this works with the new version of Circuit Playground that we're going to be launching.
Yeah, this is the Express.
Yeah, so just know that there was a lot of things that had to happen, so that's the next version that'll be coming out soon.
Yeah, this is one of the benefits of going to the SAMD processor. The original Circuit Playground has an AVR and does not work with this setup because it doesn't have the mass storage bootloader, and it doesn't use a Cortex M0 chipset.
You see how
We have
easy
to
it was
go-
to drag a file over to a drive? That's the type of gymnastics we need to do. Can't do that with the AVR.
Yeah, but that's why we have this new version coming out.
Yeah.
So yeah, the new version will be able to do Arduino, MakeCode, CircuitPython, and we'll still carry the older version. We'll just make it really clear which is which.
Yeah, I mean, there's an entire ecosystem of AVR-based projects and more that will just be straight up Arduino compatible. So we'll always have that. We'll always support that. But that being said, we need to also get to a place where people don't need to download the Arduino IDE. They might just have a Chromebook, and that's it. And it also needs to be like maybe $15 or less, or $10 maybe. And it needs to do all this stuff. And it needs to be a USB drive. And the kids need to be able to carry their code around on it. And it needs to work with something like MakeCode. So that's what we got going. This is exciting because I feel like a lot of people they weren't able to just download any software. And I think this is a good thing, more so because Python is taught everywhere.
Yeah, so you can start with something like MakeCode, drag and drop. I mean, you can see get started immediately. There's no software install. There's no drivers. There's no nothing. It just like you drag blocks around and things happen. And that can teach people like basic ideas of loops and inputs and outputs and stuff. And then once people feel comfortable with that, you can upgrade to Python. And then, you have no memory management, no pointers, but, you're having to write type text and you have to, it's all text-based. And then when you're really advanced, you can move up to C++ with Arduino. So that's the plan.
Okay.
Stand with the plan.
All right. That's everything for tonight?
That's it.
Okay. Thank you, Lady Ada. Well, that's Jessica Lady Ada. We'll be doing this all week. We'll also have a special guest, Pi Maroney, on Wednesday's show and Tell, 7:30 p.m. Eastern Time. Ask an Engineer, 8 p.m. We'll probably do a couple of Lady Ada and more. And we have some additional camera setups that we're doing at the Adafruit factory. So you'll probably see some live broadcasts during the week from Adafruit. So if whatever version of streaming you're seeing, just hit the button that tells you that there's more ahead.
Right.
This is going to happen.
Okay.
All right. Thanks, Lady Ada.
Thanks, everybody.
Bye.
Weekend update.